All right, so let's just talk about the generic methods right now. Okay, so we have spoken about the class stuff, like how we can create generic types in Java. Right now, let's just talk about generic methods in Java. So first of all, what we're going to be doing right here, let's say I'm going to create a method. Let's say show item. Okay, I want to show an item. For that, I'm going to create a method. But now the thing is, which type of item that I want to show, right? I want to show an integer, a string, a double, a float, whatever it is, right? So here, let's say I want to show an integer. So I'm going to say integer number, right? So if there is something will be passed to this, so I'm going to do sysout item is, and I'm going to be passing in this number. Okay, so whenever I'll be calling this show item, I can call this right over here, and I can pass in the number over here like this. Now the question is, if I want to pass something like this, show item, and I want to pass in a string, let's say Selenium Express. Okay, that's my channel name. Please do subscribe. So this is string, right? So if I want to pass in a string over here, then the show item method will not support. Let me make it public void show item, right? And to call this, I will be creating new app, then I'll call the show item on top of it, right? Like that. Let me just use new app dot show item. Okay, but this one will not work. To make it work, I need to create a overloaded method called show item, but here I'll be taking in a string. Okay, then only this thing can work, right? Let's say if I want to pass a character over here like this, if I want to pass in a character, let's say C, then again this will not work. If I'll pass in a double, okay, let's say show item, and I'm going to say 10.22, then the show item will not work. Again, we have to create overloaded method for the same. So I have to define something like character char. This thing will go away after that. Let's say char1. Char is basically some reserved keyword. Okay, now this thing will go away, and like that you can create one more for the double. But is it really convenient to do this thing? We may have one more method for showing a float. We have one more method for showing some other type. Let's say maybe a foo type or bar type or hello type or world type. Okay, we may have a class called watermelon. We need to show that particular object. We need to print it. So we may need to call the show item, and we need to pass an object inside that. So this method is not generic. This is not general, right? So what we can do instead, to support all this type of call, we're going to make it generic, right? So I can remove all this. I need to have one method, okay, called show item. Now only the integer one is working. Rest of the things are showing me error. This makes sense. So to make it generic, what we can do? Well, we can argue that you can pass in an object over here. Now things will work fine. But as I said, if we're going to make it object, then again, whenever we are retrieving the data, when we put inside the object, then we again need to do casting, and then we may end up with class cast exception. We have seen that kind of scenario already. But let's say I do not want to make it object type. Rather, I want to make it T type. Okay, so T means type. So I want to pass in any type of object. So T. So this is the generic thing that I have told you before. But is this thing going to work over here? No, it's not working, right? Why? Why T is not working? Because here T means what? We haven't defined that. So we need to define it over here. So we need to define it like this. So T, okay. Here, if we're going to define the type, then this thing works. So right now, even though we are not passing the generic type, this, if the app is right now generic type, but we're not passing in the type information whenever we're instantiating. So this becomes object, this becomes object. Right now, all my code compiles. But again, we got a type safety issue. We have a type safety warning. We have already spoke about it, right? Type safety means the compiler doesn't know like what kind of data that you are putting in over here. It basically can't verify the type information. So now we can do this thing. We can instantiate this as integer. Now that makes sense. Now the show item we can see is text an integer number. And now we can pass in a string, okay? Now if you're gonna see this, now this is gonna taking in a string, right? So you can replace everything over here. You can replace this to character, and you can replace this to double. Okay, this thing works. But I don't want to do this thing over here. I do not want to define the type over here. What if the class is not generic? Now I'm going to remove this information. Okay, now what I'm going to do, I'm going to remove this T from here. Okay, if I'm going to do this, you can straight away see a compilation error, because now this method belongs to this class, but here in this class, we have not defined any generic type. The generic type we basically define over here right after the class declaration. But here inside this method doesn't know what this T is. So we need to make sure to tell the compiler that this method is a generic method. And the way we can tell that to the compiler by marking this method as a generic type. And to do that, we need to define the generic type right before the method return type. So just come before void and put here T. Okay. So if you're going to put it here T, now whenever you're going to put an integer value, obviously this is an int value, but auto boxing and boxing and auto boxing concept, right? Whenever you put this, the compiler understand that you are putting an integer. So it's gonna infer this T as an integer, and whatever you're gonna put it over here, that is going to be pasted to this. Okay. So imagine if you're gonna put a new integer over here. Obviously this method is deprecated, but we can use this integer of 100. So we are creating a new integer object. Now the compiler know that we are putting an integer object. So what basically happens over here, it is going to make this T as integer, and now this T also becomes integer, right? Right over here, this is a string. So this T becomes string. So this T also becomes string. Okay. Like that for this becomes character, and whatever it becomes, the same goes over here as well. Okay. Now let's just run this. Okay. See, things are working fine. Now let's just say, I want to make this method a static method. So where I can put that static keyword, I can put the static keyword over here. Okay. Public static, then the generic type goes before the return type, then there goes the method signature. And now if you're going to do that, you don't have to explicitly make a object creation kind of thing. You can directly call the method like this. You know that well, right? So this works. Now the question is, let's say whenever I'm going to call this show item method is basically going to print the item and then going to return the same to me. Then how can we do that? Let's say we can do something like this. Return. It is going to return me the same thing. So I'm going to say return number, but this number is T. So the return type is also going to be T here as well. Okay. So there goes the complete method signature over here. Now, if you're going to do control 1 on this to handle the return type, control 1. Oh, it's just asking me to, modify this. I'm going to do 100 over here. So right now, if you're going to do control 1, assign statement to new local variable. See, it gives me an integer. Control 1, see what it is returning? It's returning a string. See what this one is returning? It's returning a character. And what this one is returning? It's returning a double, right? So what basically happening over here, just to simplify, so the formula is whenever you're going to put an integer over here, now it's my integer type. So this t becomes integer, right? This becomes integer, right? Now you can think whatever this becomes, that's basically became copied, right? And then compiler will paste it over here. So this t also becomes integer, and compiler also will paste it over here. Okay, so this t also becomes integer, right? Just like that. Whenever you put a string over here, this is a string. So automatically compiler know it's going to infer this type to string. So some kind of type inference is going on. So compiler know that you are putting a string. So this t becomes string, and this will be copied again. Oh, okay, this t will be copied, and it will paste it over here. It will paste it over here, right? So this also becomes string. This also becomes string. That's how it works. That's how easy the syntax is. Okay, so now I want to tell you a bit of tricky thing. You should keep that in mind. See, whenever I'm calling the show item method, obviously the show item method is declared over here. So I'm calling it directly, right? If it is belongs to some other class, and if it is a static method, I might have called like this. Let's say app.showItem, right? And I will replace the same to all of my method call, something like this. Now, one thing that I have told you, whenever you pass 100 here, the compiler somehow guessed that this is an integer object, and this t has been inferred to integer, right? Like that here it is string, so this t has been inferred to string. So some kind of guesswork is going on, and compiler is setting up this t accordingly by looking into the value that you are passing, right? But here, if you want to explicitly define it, you can also do that. And to do that, you have to pass in this parameter before you make the method call. And you have to pass in the type of it, let's say integer here, okay? And this is some kind of a weird syntax if you're going to look into this. But this is pretty straightforward. App is the class name, and method is showItem, which is a static method. But this value that you are passing inside this method is 100, which is an integer. So you're passing the type over here, so this t will be integer straight away. The compiler doesn't have to guess it what it is. Same thing over here as well. Here you can define the type to string, okay, if you like to, okay. If you don't like, then again the type inference will come into the place. So if it is required and the programmer doesn't want the compiler to do some guesswork, he can directly define the type over here, something like this, okay. So this is one more point you remember for now while practicing the generic methods. But now I'm going to get rid of this. I want you to create another generic method for me, which can take any kind of array and can print it. For an example, I can write a public method. Let's say public static is the modifier that we have over here. And then this is a void method, and I have a method called print items, okay? And here inside this print items, I want to take a one-dimensional array, but this is a T array, okay? This could be anything. This could be of integer type array, or double type array, or string type array, or foo type array, or something, okay? Let's say I'm going to say items here. And this T can be anything. So I want to define this generic type over here, T. You can also make it anything. You can make it, let's say, U as well. So if you're going to make it U, make sure this is also going to be you as well, right? It's up to you. And here basically your generic types goes. And now what you want to do, you want to iterate over it. So you want to have a for loop, okay? And you're gonna say you item, and you want to iterate from this items. And this items is gonna have type of u object, okay? It can be anything. It can be integer objects or string object. This item will be a type of u array. And here you can just print out it over here. Sys out, and let's say item here. Okay, so now if you want to use this, you can directly call this, or you can call it using the class name. So app dot print items, and you can pass in a string array, let's say. So new string, and over here you can pass in some string type of data. Let's say Vilas, Selenium, Express, something like that. You can use the same print items over here, and you can pass in a bunch of integer over here. So you can just pass in a bunch of integer. Okay, so let's just see if these two things are working. Let me comment this one first, and let me just try with the string thing. So run this, and there you go. This works fine. Now let me comment this one and uncomment this. Let's just see whether the print items can take a array of integer. Okay, so run as Java application, and this also can print this as well. So your generic method is working fine. Now this thing works as well, right? I think you understand this as well. I want to show you one more syntax over here. I'm going to get rid of these two things. See, here you are just defining the T over here, or U over here, which is my generic type. And here I have one parameter here. So I am defining one type over here. If I want to define couple of types, okay, I can also do that as well. Let's say I'm going to have one more method which can print items, but this is, let's say, print multiple items, right? Let's say here I want to pass couple of things. I want to pass T, okay, which is going to be my first parameter, then U, which is going to be my second parameter. So here I have two types, right? And I want to have my sys out over here. I'm going to say T dot toString, okay? And also I'm going to have another sys out over here, okay? And I'm going to say U dot toString. I want to print this couple of thing over here. But now if I'm going to make it, let's say public static, and this is a void method, this is not going to work because this type I haven't defined. So now before the return type, you can actually define multiple types. You can define T type here and U type here. Now you'll see this compilation error is going away. Well, I have to mark it as toString. Okay. Now, if you want to call this method, you can absolutely do this. App dot print multiple items, and here let's say I'm going to pass in a string, let's say a Vilas, and I'm passing a integer which is 100. Now this Vilas is a string type, so T will be string and this U will be integer. Okay, let's just see if that can print this couple of things. And there you go, Vilas and 100. Now, if you want to pass in those information over here, if you don't want the type inference to go on, you can pass the T as string type, okay? And you can pass the second type as integer type, okay? Whatever you wish. This is also another way of calling this method by passing in the type information that you are passing over here in the parameter. So if I'm going to run this thing also should work fine as well. I think this thing is making sense, right? So this is how we can define multiple parameters over here. Okay. Not only in the method, in the class also you can do that. A very famous example also you might have seen, that's called hash table. So I want to just drag your attention to this as well. So you can define a class here. Let's say class hash table is the class name. And inside this hash table, I want to have the key type and the value type. Okay. So I want to store, where is my cursor, man? Somehow my mouse is not working. So let me just complete this tutorial. Let's say if you want to define a hash table, so you need two things. You need a key and you need a value, right? But this key is going to be what type? Let's say this is going to be of some type. And this is also going to be some type. So I'm going to make it K and V, which does mean that it can be anything. K can be anything, V can be anything. So over here inside the hash table, you can declare those generic types over here, K and V. And here you can make them private. So private key and private value, right? So this is how I can define a hash table. I can give a constructor over here. Okay, you can take the key and V information and can initialize this. And to access the value for key and value, I'm going to give a getKey method. So this is how I can define multiple generic type over here for my hash table. Okay. Now to initialize the hash table, I can go to my app class, and right over here, I'll be removing this code, and I can say like this hash table, which is coming from the generics3.demo. Note that we have also a hash table class existing in Java, but I'm going to use this one, the one that I've created, and I can define the key type and the value type. Let's say the value is integer, the key is string. Okay. Let's say hash table 1 is equal to new hash table. Okay. And I can define the generic type over here. If you want, you can repeat yourself by typing string and integer again. But as I said, if you do not define this, again, the type inference will go on. If you're going to just do this, the compiler will look into the left-hand side and will decide that, okay, this is going to be string and integer again. So you don't have to be redundant. I told you this feature came in Java 1.7 version. So here you can define a string, let's say a village, and let's say here the value is some integer value, which will be 10. And same way, you can define multiple hash table value over here. So I can make it both as a village, and let's say the channel name is Selenium Express. So both are string. And to get the value, we can do the same thing. If you're going to do hash table 1.get key is obviously going to be string, because that's something that you have defined over here. So if you're going to do control 1, you're going to get a string back. Assign statement to a new local variable is going to be a string. If you're going to do hash table 1.get value is going to be integer, because that's the type that you have defined over there. So this is going to return the value to you. Okay. And if you want to print them, you can easily do that as well. Okay. All right. So here is a very important question that I want to ask you. By the way, my mouse started working, so I can continue a little bit. So I've given you this example, right? This hash table, you can instantiate. Look at this hash table. This one is string. This one is integer. Here the key is string. The value is also string. So one hash table, we're instantiating, but passing in different types of parameter during the instantiation. Okay. So here we're extracting the key, the value from the hash table 2. So the key and value are both string in hash table 2. And there goes the print statement if you're going to print it. So things should work as expected. Okay, the key is Vilas. The value is Selenium Express. Okay, if you're going to make it 1 and 1, the hash table 1 value is integer. So this should be an integer type. Run this. Things should work as expected. The key is Vilas. The value is 10. Okay, now I have a question here. Look at your hash table class. Okay, so my question is, can we make this value as static? Now you can obviously say there is an error which is straight away compiler is giving you and just saying cannot make a static reference to the non-static type v. So v being the parameterized type, or sorry, v being the type parameter of this hash table, is not allowed to be static by the Java compiler. Okay, so in Java, the variable that you are declaring should be instance variable or non-static variable. You cannot make them static. But the question is why? Why Java compiler is not allowing me to set this value as static type? This v will be defined in the instantiation time whenever we'll be instantiating the hash table, and we'll be passing the type parameter over here like this. But straight away, Java is not allowing me to do that. Why? Well, I'll come back to this question because there are two parameters over here. Might be a little confusing. So let's just do one thing. I'll go to one of the other class. Okay, this is another class that you have created. Okay, and this is called box. Okay, so here all this information let me remove. Okay, you have a box of t type. The value has been defined as t, right? And how you are instantiating this box t and setting this value using this set value method. So here you're instantiating the box with integer type. So you can just do box1 dot set value and it will be of only integer type like that. Box2 dot set value, and this could be of string type, let's say Vilas. Okay, now tell me here this value is non-static. Can we make it static? As I said, no, we cannot make it static. Okay, Java will not allow it. Now let's just try to find out the answer why. Okay, look at this. So for an example, okay, think normally right now. What is happening here? Now this is non-static. This is instance variable. So we are creating couple of box instance, and while instantiating, while creating the object of the box, we are defining the type parameter, which is value. And by the way, this is a instance variable. Instance variables are part of object. Let's say you are creating a box object and you are specifying the type information as integer. So this value here right now, it is storing some integer value over here. Okay. By the way, there is a type erasure concept. You know about it. Here you are mentioning integer, but this is all for the compile time. In the runtime, this value will be become of object type. That's a different thing. Okay. But the thing is, as we are making it parameterized type, obviously this parameterized type is t. So this becomes t. So obviously, we are setting that information over here. Okay. During the time of object creation. And this value is part of the object. This value is right now not part of the class. If it is static, that means it would have been part of the class. Now we can create different box object. Okay. And for this, the value, let's say the value is Vilas. It's a string. Now the value is different. Okay. So for another box object, the value might be something else. Let's say the value is 20.2, which is a double. Okay. Now, what is the important consideration is here, using generics, we don't have to create 3 different box class with three different value type. One is as integer value, one is a string value, one is as double value. We don't need to create three different box class. Generic allowed us to have one class, and for this box objects that we have created are all belongs to this same box class that we have over here. These are all instance of the same box class that we have over here. Okay, which is good. So we can store any type of data inside this value, and we can do all this because this value is a instance variable. Okay, and the instance variables are belong to object label. Okay, but if this t would have been a static type, okay, by the way, this is not allowed. Java doesn't allow that. But imagine if this is static, then what would have happened? Okay, let me remove all this thing first. Okay, imagine right now, whenever the box basically loads, okay, if this is a static, okay, this t is a static, then static means it belongs to the class level. Okay, so when that class loader will load the box class, okay, it will load all the static variables. The value, there is a static variable called value, so it will load it. Okay, it will load it over here because the value belongs to the class. Okay, and first of all, whenever it is loading this value, it need to find the type. Now we don't have any type whenever it is loading this. Its t is not defined. T will be defined whenever we'll be creating the object for that. Okay, but however, okay, let's just forget about that. Now this value over here, we don't have the type defined over here. So this first is a wrong thing. Okay, if that is the thing, then it might cause some weird behavior and there will be a lot of other things will happen. But first of all, let's say right now this value becomes to the class level. Okay, forget about that constraint that we need to define the type over here, whether the value type is integer, whether the value type is double, or it is some specific type for this value we need to define if it is the static variable. But here t, we are not initializing right over here. We are not specifying the t right over here. So first of all, that's a wrong candidate for the static level variables, right? This is the first thing. Okay, forget about that. Let me remove this thing over here. Imagine there is something called value over here in the static level. What is the need of the static variable, guys? When do you need to go for static and when you need to go for non-static? Imagine you have a class called student. Okay, this student objects are belong to one particular university. Okay, let's say there is id, there is name, and there is college name. Okay, college name variables are there in this class, in this student class. What variable will make it static? What variable will make it non-static? Well, you'll think in this perspective. Non-static variables means they will belong to the object. Okay, they will belong to the object itself of student. The static variable means they will belong to the class called student. Now, each student will have a different ID and different name. So for each student object that will be keep on creating like this, let's say you'll have an ID, you'll have a name. You'll have an ID and you'll have a name. Okay, let's say ID is 2, this is ID is 1, name is, let's say, Avilas, your name is Ramesh, your ID, let's say 3, name is something, ID is 4, let's say name is something. Okay, we'll have different names here. But now for every time you create an object, you need to allocate memory for this instance variables, right? ID, name, ID, name, ID, name. You need to allocate memory for each of this because they are containing different values. Okay, but what I see here, the college name is going to be same for each object, each student object. These are all student object. Okay, so for each student object, I know the college name will be same, right? So this is also a student object. So if college name will be same, then I don't need to make it non-static. If this is an instance variable, then here also there will be a college name, 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 but end of the day their value is same. This student also reads in the same college, this students also reads in the same college, this students also reads in the same college. So basically the values will be same. So why to waste our memory? Okay, if I have 100 student object, then I might have copied this college thing to 100 different objects, so that is not needed. So at that time what I can do, I can remove this college information from this student thing, and let's say I have the student class here, okay, which are having all these objects created. Now I can make the college name as a part of the class, okay, by making it a static variable. Then this college name will be shared with all these objects, isn't it? So static resources are being shared with all your Java objects will be sharing the static resources. Let's say the college name is XYZ. Then this guy will also read, this guy also will read, this guy also will read, this guy also will read. So one memory location, but every object they can read the class level information right from here. So the college name is shared, it's being shared with different objects here. Now coming to our generic thing, right? So let me remove all this thing. So imagine here we are creating a box object, okay? And imagine we have defined TS static and Java is allowing us, okay? So for this box, we are creating a box object and the parameter type is integer. We are setting the value as 100, okay? Now let's say the box object is here. Now we are setting the parameter type as integer and the value as, let's say, 100, okay? Now imagine this. Now we are creating another box object, okay? Now for this also, this value is static, so it's a class level thing over here. Now this want that value to be string. Now this want to store a Vilas here. Now it want to store the value as a Vilas, which is a string. Maybe somebody else will do box of double. They will instantiate like this and they will set a value 20.12. Okay. Now the value need to store 20.12. Now think about it. And this is a class level variable, right? Value. Now how it will store 100 of Vilas and 20.12 in the same time. In the same time, there are three objects. One objects want to store 20.12 over here. So for this object and this object, they want to store 100 here. Somebody wants to store a Vilas here. So three different types cannot be stored with integer, right? So we might need integer value equal to 100, double value equal to 20.12, string value equal to Vilas. But these are not three different classes. This is one class, one variable box. So the type cannot be different for each object here. Okay. And that cannot be shared with all the objects, because if this object is a double one, it wants to set the value as 20.12. This will be shared with this will be shared with this, but it doesn't want the double value. This want the string value as a Vilas, right? So we cannot have multiple values like type for the values, right? And here the type eraser concept will not work. You cannot say, okay, let's just go and make it object, because the type eraser concept only works with the instance variable, okay, not with the static variable, right? So for that reason, all these objects actually cannot put the appropriate value inside this value. So that's why if I can stop this, this T cannot be static. Okay. If you want to make it static, then it will complain. So this T is a class now. If you're making it static means this is a class level thing. Okay. Make a static reference to the non-static type T. So T is a non-static type. Non-static type means this T is a generic type and that belongs to the object. The generic type belongs to the object. So here we are creating the object of the box and here we are specifying the type. Okay. So the generic thing is basically the object related thing. So the T is a class level thing. So you cannot make a static reference to a non-static type T. So T is a non-static type. So you can't make it T over here. Okay. And I hope this makes sense. Even in the set value, let's say if I'm making public static, okay, see this still complains. Same error, cannot make a static reference to the non-static type T. If it is a static method means it belongs to the class, right? So at that time, you cannot make use of the generic type like this. Okay, make sure you understand this. And the same explanation goes for this as well, the hash table thing that we have created over here. And I asked you why I can't make this value as static. If this is static, you will say something like this. Okay, you will say like for this, let's say for hash table integer, let's say value, I want to set to, let's say value is integer here. So I want to set this value to 100. And let's say this guy will say, okay, for hash table string, okay, for this, if we're going to make this value as static, right? You want to access this value, right? And here the value you are defining it as string. So you want to store, let's say, Avilash. Okay. So how is that possible? One value, okay, which is a static value, which will be shared by all the objects, right? At the time, you cannot assign two different values to that, right? That's impossible, right? So for that, you need to create two different values variable, right? So we're not doing that. We are working with generic is completely meant for the object level, not for the class level. So the static are class level thing. So they cannot be, static, right? Hope this makes sense. If somebody asks you this in interviews, let them know. See, generics, right? You cannot use static or class level thing. So they are being used in a different way, and the type eraser doesn't work with static members. Okay, remember that. But by the way, one more question I have. Okay, let's say this is a class, whatever class. Okay, I don't care about this. Can I define a method here? Public. Let's say void. Let's say some method. Okay. And here I want to define the type T and T here. Okay. And I will make this class, which is part of this, where the method is part of it, as T. Okay. And now I'm going to make this method static. Okay. So this is not allowed because this T is a generic type thing, okay, which is part of this. And you can only get the T value whenever you initialize the f class as f of integer or f of string. So this T belongs to the object level. So you can't use it over here in a static method because the sum method is part of app class, not part of app class object, which is app of integer or app of string. And here we go, the method. Here we have T. This is not allowed. But if I'm going to specify the generic type here explicitly, then what will happen? See, right now, there is no compilation error. So what do you understand about this? This means here, this t, whatever you pass, doesn't matter. That is being overridden over here. This t is overriding that class level t that you are defining over here. Okay, that means that this can be anything. For an example, here you can just do some method and you can just do 10 for an example. Now if you're going to hover on this, see the type which is getting passed here is integer, and this is a integer t. Some method is right now integer t. Because you're passing integer, this is in for to integer. Okay, so that class label t is now being override by this t that you are defined. Now let's say if you're gonna initialize the app of t to app of string, now the t becomes string here for the app type object, which has nothing to do with the sum method that you're passing 10 here. Because here for the sum method, the t becomes integer and it has nothing to do with the app type string where you have created the object for app. Okay, so this is how we can make a generic method static. And if you understand this much, I'm okay with it. But if you want to dig more, if you want to understand if type eraser concept works with the generic method which is static, then I'm going to give you a bonus lecture in the end of the video. You may choose to watch it. I will go deep and will show you different things. If not, then you can bypass that. But for now, let me switch to a new concept and let's just check how to use all these generic methods in real time. Okay, let's just try to do one thing. Let's just try to see some of the generic methods here. Well, one thing you understand, guys, generic methods are mostly the static methods. Okay, and they are used for a lot of utility methods if you want to develop, which will be helpful for different instances. You'll find all of those util methods as generic. For an example, if you can go with your collections class, which has a lot of utility method, you will find this collection class. See, all these methods are static, and see the sort method, generic type. Okay, look at this sort method. There are some generic type here. Okay, maybe something like this you might not able to understand right now, but that's a different thing. We'll talk about all this super thing. But you look at this method here. Iterator binary source tree is a static method. Okay, that's what I want to point it out. All these methods are generic. You can see it's taking t and using it somewhere over here. Like this you can understand right now. T key. So whatever you are going to pass over here, that will be this. Okay, so if I can scroll down, let's just see some easy methods here. Let me do a control O here and look for some method. Okay, look for this method. Replace all. Okay, I think you can pretty much understand the syntax right now. What does this mean? Replace all means it takes a t. The t could be of any type. It can take a list of any type. Okay, list of integer, double or whatever. Then you can give a t old value and a t new value. So t, if it is integer, if you're passing a list of integer, then you can give a integer which is old integer, and if you can give a new integer value over here, and the old value will be replaced by the new value. That's what the replace all method does, and it can support any type of list. Let's just try to use this one. Let's just go to app.java. Okay, let me remove this app.java. Let's say I want to use collections.replace all method. The first one, it takes a list of t. So I'm going to say list of, let's say string. Okay, string list is equal to new array list. Okay, and let's say inside the string list, I'm going to add some strings. Let's say apple, and string list dot add, let's say a banana. Okay, something like that. And I'm going to be passing in this string list over here. If I can put it over here, now it text object because I haven't defined anything. So I told you if I'm gonna put here string, that means now the replace all text string. But if I don't want to put it over here, I can just make collections, my class name, static method, replace all, pass in this string list. Now, if you're going to hover on this, you can see it's automatically compiler guessed right now is string, right? And now I want to replace all my apple as orange. So this is my old value. So this is also going to be a string because the T is right now a string. Okay, whatever this is, now this is going to be same, this is going to be same, this is going to be same. Okay, so I need to pass, let's say, I want to pass my old value, which is apple, and I want to change all the apple to orange. Okay. So I'm going to put it over here. I'm going to print my list before doing the modification, string list. And I just want to print this again, Control C, put it over here. Sorry, put it over here. And after making the changes. So look at that. Previously we have apple and banana. Now we have orange. Apple is replaced as orange and this is banana. And if you're going to make this apple, if you don't want to put a string, if you are putting an integer, then there will be complaint because, you know, the TTT in the type in the collection is not applicable for a list of string, integer string, because all this T are string only. If you're going to put over here the cursor, you're going to be finding this. So this will be this. So I think you'll be able to figure this out right now, and you can see the method like this and you won't be confused. Let's just try to find some more method. So let's just try to do a Control O and look for something called empty list. Yeah, look at this kind of method. Or let's say you'll have empty set. Something like this. Look at this. So if you're gonna enter this empty set, look at the syntax. Here, it takes T, okay, returns you a set of T. So if you're gonna pass an integer, it is going to return you a set of integer, but it doesn't take any parameter. Okay, so look at this. There is no parameter defined, but it is returning you a set of T, right? The empty set, or you'll find empty list right over here. Look at this. It doesn't take anything, but it return you a list of T. Okay, so how does this thing work? Let's just look at this. So after Java, so this is another util method. Let's say I'm gonna do collection start empty list. That is a method. If I'm gonna use this, now this empty list, if I'm gonna hover on this, I haven't defined the type. That's why automatically it is set to object. See, empty list. Okay, it doesn't take anything. I can directly call it using the class name, which is collections class. If I'm gonna go back, so I'm not defining anything. So if I am specifying here string, okay, if I'm going to hover on this, now it is going to return me a list of string. But if I'm going to remove the string, if I can hover on this, it can return you a list of object. But let's say I'm not defining anything over here, but I'm doing, let's say, list of string. Directly can I do? And string. Can I do this? Absolutely. If I can hover on this right now, I can see it is returning me a list of string. This is what we call the target type. We haven't defined the T here. So in the empty list, the T is not been taken in the parameter. So if there is no parameter is present here, the compiler is not able to guess, right? The type inference cannot happen, but it will happen. How? Now the compiler will look into the target type here. So if the developer is writing your list of string, this will be a string list. Okay. So what happened? Oh, it is already there. Let's say if I'm going to change it to list of integer, then the target type is list of integer here. Then this empty list will return me list of integer. Hope this makes sense. So whenever you pass in the parameter, compiler will do the guesswork by looking into the parameter thing. If the parameter is not there, not present, then the compiler will do the guesswork by looking into the target type. Okay, that's good. So this is good. I'll actually give you another example. Let's just try to create a list. We have a list here. Okay, and let's say, can I just do string list dot toArray? Okay, there are a lot of toArray method. If I can use toArray, this is going to return me what? Okay, this is going to return me an object array. So this string list, whatever it has, all these things, if I'm going to do control1 assign statement to a new local variable, it is going to convert it to an object array, right? And if you can look into the toArray syntax, look at this, it's pretty simple, toArray, and it's giving you an object array, right? But there is a problem, right? Everything that I have inside the string will be converted to object type. So I have only option to do a for each loop, and the type I'll be retrieving it as an object. So I can just do object O, and I can just say array, and then I'll be able to print out everything that I have in the list. So if I'm going to run this thing should work fine. But this toArray has another version. Look at that. So if I will go to the toArray, scroll a little bit of down, see, I have another example. And here I have a tArray. I need to pass here a tArray. Unlike this toArray, here we are not passing anything in the parameter. But here we have to pass something in the parameter. We'll be defining the t. Okay, if we are saying, okay, we want an integer array back, we can get an integer array. If we pass the t as string, we'll get a string array back. So here we're going to be specifying our t, okay, what type of array we want, and that is the type of the array we're going to be getting back. Okay, let's just see how that works. Let's say here I want to pass, now this toArray is giving me an object array back. Let's say I'm going to say new string array I want. So new string of 0. How do we, this is how we create array, right? Just define the array type. Let's say string. Now if you're going to hover on this, see what type of array we are getting back right now? String array. So if you're going to do control1 assign statement to a new local variable, we're going to get a string array back from the string list. Okay. If you would have an integer list, you can define the integer array over here and you can get the integer array back. And that's the power of this T thing. All right. So I just want to show you a couple more examples and then we wrap up this session. Okay. So I want you to see all this fancy looking thing so that you can at least get some idea what's going on, right? So you don't have to be very much serious about it, as we have used few generic methods. So you are I'm sure you are getting acquainted with it, and in future we'll be learning some more about the generics like wildcards, upper bound, lower bound, and then things will be pretty much easy for our day-to-day code. But yeah, I just want to show you a couple more things. Just answer me this. Here we have created some methods. Maybe I'm going to create another method here. Imagine I'm going to create a method here called, let's say anything. Let's say my method 1. Okay. And let's say this is a method. And here I actually want to accept a couple of parameters. So one parameter I'll define here. Let's say, do I have any class level parameter? Yes, I have a class level parameter. Let's say this is a non-static method. Okay. If it is a non-static method, public void, then can I use the class level parameter over here? T? Yeah, absolutely, because this is a non-static method. So I can use the class level parameter. So if it is static method, there would be a compilation error. But let's say this is a non-static method and I am overriding this T as well. Okay. So this generic type is specific for this method. Right now, I will not be dependent on the class label T. So I have already discussed about this. So this is where I'm overriding that T that we have over here. But generally, this is a little confusing. I will not recommend that if your class level type parameter is T, and if you're doing so, you are just overriding that type. So better you can take something else. Let's say U over here and U over here, just to make sure the things are looking a better for the other developer to read. Okay, so they will say, okay, this is the generic type method and here is the type declaration goes for the U. But yeah, just let's say I'll just put it as T because I want to create some confusion. But let's say this is T, so anyhow this value whatever will pass, that will be overridden. But I have one more question. Let's say this is T. Otherwise, I will not define this T over here. So I want to use that generic type T over here inside my method. That is absolutely possible. As I said, this is an instance variable. But I will take another parameter here. Let's say E. Okay. And here I will define this E over here. Is it possible? E? It's absolutely possible. So one parameter will be taken from this T while the instantiation of the class app, and that will be replaced as this, and this E will be defined by the developer when he will be using this method. For an example, if I will create the app class instance, let's say app, let's say new app, okay, and I will be passing in, let's say integer here. So this integer will be the value for this T, and this integer will go over here, and then I can do this. So I will instantiate this. Let's say I'm going to use my method. The first parameter is integer already, as you can see, because there goes my T, and the E I can define over here. Let's say here I'm passing in 100, and the E over here, let's say I'm passing in a string, let's say Vilas. Is that possible? Yes, pretty much possible. Now, if you're going to hover on this method, you can see I'm passing the string type here for the second parameter, and integer T goes for the first, then string E goes for the second. For the E becomes string because that's something that we have passed, and the type inference goes on. You can also specify that value over here, let's say string for this, okay, and the string value is basically for the second value, okay, and for the other one you have passed it over here, okay. So you actually cannot pass couple of value over here. Let's just check, because if you can hover on this, you can see the first one is already taken as integer, because that's what the type declaration there where the type declaration goes. And if you can hover on that, you need to only pass in this E value. So you just need to pass this string over here in order to invoke this method. Okay, hopefully that makes sense. Let me remove this right now. Let me give you another example. Okay, here is one last example. Okay, tell me if I'll have a method here called public, let's say static is a static method. Then I have my generic type over here, let's say T, and I'll have the return type, which is T. And let's say this is my method 1, and here I will accept couple of parameters. So if I'm gonna do, let's say T, let's say parameter 1, and another parameter of the same type, so T param 2, okay. And let's say I will be returning, let's say something, maybe I'll return, let's say param 1. Okay, and right now let's just try to invoke this method called my method 1, and this is a static method. So I'm gonna say my method 1, and I have to pass in couple of parameters. So normally I need to pass thing like this. Let's say avi. The second parameter is going to be avi as well. Okay, and this works good, right? So this T becomes string. So if I can hover on this, the compiler guessed it. Both of this value are string. So this T becomes string. It's a simple use case. If I'm gonna put it 100 and 100 over here, both are integer type values. So if I will hover on this, the values become integer, and this T has been inferred to integer. Now I have a question. If I'm gonna put 100 here, and if I'll put a string here. So what will happen? Compilation error? No. Why is that? See, there are two values, okay? So there are two parameters, but the parameters is going to be of a T type. It's going to be of a T type. T is a specific type. So what is the specific type? Integer, I'm saying. But well, if it is integer, this one is going to be integer. This one is going to be integer. So I can pass in 100. So 100 goes over here because this becomes integer. But avi, this is not string. This is an integer because if this is 100, okay, this is integer, this is integer, this is integer, then how come this avi is getting fit into the param 2 and I'm not getting any compilation error? And there comes another concept. It's the same concept actually called type inference. See, now if I'm going to say before calling this method, let's say I'm going to call this method, let's say app.myMethod1. If I'm going to say, hey, I'm going to be passing in integer, then there is a problem. Okay, I'm straight away getting an exception here, say error over here, and it will say parameterized method integer. This should be integer. This should be integer. So how come you can pass a string over here? This should be an integer. Okay, if this one will be this. Okay, so both of this will be integer. But now in the other case, if I will not be passing this, but I'm going to pass in an integer in a string, it is not complaining because the compiler is using its intelligence and it is just finding, okay, this 100, I need to fit into this T, and this avi also I need to fit into this T. So it is going to take the super class of this couple of objects, right? It is not the super class of this, obviously object, the super class of this is obviously object, but the integer class and the string class does also have a immediate super type. And what is that? Let's just see. If I'm going to do Control-Shift-T and look for, let's say, integer class. Look at this, integer extends number, okay, and comparable, and this and this, okay. If I'll go to the number class, the number implements serializable, okay. So if I'll go back to the app.java, for the second type is string. If I'm going to do Control-Shift-T and I'm going to say string here, okay, I'm going to go to the string class. See, string is also implementing serializable. Number is the super type of integer and it also implements serializable. So both of these guys immediate super type is what? Object or serializable? Serializable. Then the serializable obviously extends to object automatically. But the immediate super type is serializable. So if I'm going to hover on this, so see, this is serializable. Okay. So normally you can see if I will not use generics over here. So here I'm going to do serializable, and this is also serializable. Okay, and this is also this T is also serializable. This is a normal method. See, this method compiles because 100 we can put over here, and avi also we can put it over here. Okay, so now I'm gonna remove and get back my generic method that I have. So that's how it works. So if I'm gonna hover on this, see, it has taken the parameter as serializable automatically, and type that we are passing is serializable. Isn't it cool? And also what we can do, we can hover on this, and this returns a serializable as well. So I can just say serializable, and let's say a data, and if I'm going to print out this data, then obviously I'm going to get my data back, and the data will be what? This method returns what? T. What is that T? Param1. What is param1 that we are passing over here is 100. So let's just see. If I'm going to run this, I'm going to get 100 here. You understand that? This is how the type inference is going on here as well. Okay, this is getting decided using the immediate super type which is available for this couple of things. Let's say I'm going to do this. Let's say I'm going to do I'm going to create a custom class. Let's say class animal, and this animal doesn't implement serializable. Okay, so now let's just do one thing. The first parameter is 100, which is an integer. The second parameter is new animal. Okay, how can you feed in right now? These are two different types. Okay, will it work? See, it is working. Now if I can hover on this, see, it has taken the immediate super type of both of this thing. 100 is a integer immediate super type is number, then number super type is object, and animal is a custom class, it doesn't implement serializable, so immediate super type is object. If I'm going to do implement serializable, okay, let's just see, hover on this. Okay, see, it is taking serializable right now because animals implement serializable, integer is also implement serializable, right? You got that right. So this is how that thing work. Okay, what if I'm going to do this, if I'm going to put a new array list, okay, and if I'm going to put new hash set, okay, then what is going to happen? Okay, what is going to be the immediate super type? Over on this, see, it is abstract collection, because the array list, if you can see this class here, okay, extends to abstract list, extends to abstract collection, right? Let's just go to the hash set, okay, extends to abstract set and extends to abstract collection. So the immediate super type is, you know, that abstract collection. So the return type is also going to be abstract collection. Okay, I think you understand that, right? So how this type inference is going on. So that's pretty much it. Okay, so before you go, I'm gonna give you a couple of assignment. Okay, try to do some hands-on with this generic methods. We're gonna be keep on using all this thing. This is most syntactical thing we are discussing right now. What works, what doesn't work. So there are also a lot of other stuff. We're gonna be talking about that whenever we'll be discussing wildcat and bounds and all that. But right now, you go ahead and help me to write a method. Okay, which will do this: convert array to collection. Okay, and this method you will be writing. Okay, so what you need to take, you need to take an array. It can be of any array, integer array, string array, or whatever. Let's say array object you're gonna be taking, and then second one you're gonna be taking a collection. Okay, so I'm gonna say list of any type. Okay, so you're gonna be taking list of any type. Okay, maybe whatever list of any type you can give, and an array of any type you can give. So what you're gonna be doing, you're gonna be returning a list of t. Okay, and this is going to be a public static method. Okay, and this t you also need to define here like this. So what this method is going to do is going to take an array object and any list object. Okay, and it need to return what? It is going to return a list back. Okay, so maybe we can return this list, but before returning this list, we need to make sure whatever elements that we have in the array, we need to put it inside the list. Then how can we do it? Very simple. You can just write a for each loop. Okay, you can just write let's say this array object you can take, and then you can just write t object value. Okay, so t can be of any type. We just want to iterate this array object, and we need to put it inside that t type. If it is an integer array, this t will be integer. Okay, and we need to do one thing. We need to do list dot add of object value. Okay, now like that we can put everything inside that list, and we're going to be returning that list of t here. Okay, let's just see whether this works. Let's say I have an array. let's say I have an integer array and I'm going to initialize it straight away. And I'm going to say I have 10, 20, 30, 40, and all that. Okay. And now I will do one thing. I'm going to create an array list. Okay. Over here. So I'm going to creating a list of integer here. Now I can call my convert array to collection over here. I can pass my int array. And I'm going to pass my second type here, which is list of integer. Okay. So if I can hover on this, look at that. The type here becomes integer type. It takes the integer array and it is a list of integer it is accepting, right? So if I can do this, okay, this is going to return me what? This is going to return me a list of integer, a list of t it is going to return me. So if I can do control 1, assign statement to a new local variable, let's just try to print out our list, sysout, convert array to collection, this variable. Let's just run this, run as Java application. Look at this. This works, right? And the same thing will work for a string array. Maybe I'll just change it to string. Okay, I did put some string value. Now, let's just do one thing. Now this doesn't work because here in the parameter, we are passing int, let me change it to string array. Okay. And let's say this is a list of string. Okay. So I'm going to pass in the string array over here, my list of string over here. Now, will it work? This code will not work because string array we are passing over here. Okay. And this is a list of string. This is a list of string. Okay. Now tell me what is the issue here. Now we are telling the compiler that this is going to be of string, a list, string array, and this is of list of string type. So compiler will apply the intelligence and gonna, put this t type over here. Now what will be the t type? What it will pass? Can you put over here your cursor? So you can see there is a type mismatch over here because list of string to list of integer. See, here in the parameter only, we are passing the value as string. Okay. So the target type is right now list of integer. Now compiler will decide the target type based on the parameter type. If the parameter type is not there, then it will automatically guesswork the target type straight away. But right now we are passing in the parameter type. Okay. And this is of string type of array and string type of list. Okay. Then this has to be list of string. Remember that. Okay. And now this works. And if I'm going to run this should work, right? So your method works pretty well. Now you go ahead and do this for me and put it in the comment if you have followed the tutorial so far. You need to do this. You need to create a method called public static sum. Okay, this is your assignment. You have to take couple of parameter. Okay, let's say int a, int b, but you need to make it generic. Okay, and you have to return, let's say here int, and you have to return a plus b. Okay, so you go ahead and convert this method to a generic method so that I can pass in a double, will get a double back. I can pass in a float, get a float back. Okay, seems easy, right? Go ahead and try this and tell me if it is easy or you have Googled as, ChatGPT the solution. Let me know the solution for this. Okay, convert this to a generic method and let me know how to call this. So that's pretty much it about your generic methods. More things are coming up. There are still a lot of things remaining. But this is pretty much it. I'll see you in the next video. And in the next video, I will tell you something which is very, very, very important. What we call covariance in Java. Okay, covariance is allowed in generics or not. We'll be discussing that. For an example, this is what going to be the topic of our next video. Let's say we can just do list of integer is equal to new array list of integer. Can we do this? Can we do this? Absolutely. This is super type. This is subtype. Subtype object. We can absolutely put it inside the super type reference. So I can absolutely do list of integer is equal to, or list equal to new array list. I can simply do that. Not a problem, right? Super type, array list is subtype. So we can absolutely do this. Now I can also do this. List of integer is equal to array list of integer. That's also fine. So that's all good, right? So base type, and this is also the base type. So base type, I can take the super type and I can take the child type over here. Okay, super type is list, child is array list. That's fine. So inside the generic type part, can I take here number? Okay, and can I take here integer? Well, it's not allowing. The integer super type is what? Number, right? So go back. So I'm putting number here and I'm putting integer here. Then why it doesn't work? So let's just make both as array list. Sorry, go back. Let's just make both this as array list. Okay. Now look at this. This is array list. This is array list. But here I'm taking number. Here I'm taking integer. It's not working. Why? So can I do this? Array list of object. Okay. Then array list of integer. Why I'm not able to take this? Because integer super type is object. Why I'm not able to do this? But I can simply do this. I can do object obj is equal to new, let's say integer. Okay, so integer, let's say 0 or something. Okay, I can do this. Obviously, this is deprecated, but I think you know this is an object, right? This is fine. I can take this as string. Okay, this is allowed. But if you can go back to your previous example, array list of object is of array list of string is not allowed. So the covariance is not actually working with generics, but can we make it work? And is covariance is allowed? If not allowed, then why? What are the wildcards? All these things are coming up in the next video. See you there. Practice all this. And by the time you practice, make sure to do like, share, subscribe, what all that are available. Just make sure you are doing that. And also make sure to put the comment for the generic type replacement for this method and convert this to generic type and post it in the comment. I'll try to check it out and I'll see whether you have done the research and able to convert the things. That's it. I'll see you guys in the next video. Till then, bye-bye, take care, and happy coding. Hey, I'm recording this video during editing because I feel you might have a confusion here. See, I told you if this class app that we have over here, let's say if we have something defined here called T, this basically belongs to the object, not to the class, right? So basically, if we have something defined here, TT, this is a non-static variable. And whenever we initialize our app, something like this, and that time, this T becomes integer, right? And we can set value over here. Let's say app dot T is equal to, let's say 10. Integer dot value of 10. And I'm creating an integer object and assigning it to here, right? Because I told you this T right now, if you're going to make it static, this belongs to the class level. And this T here that you are defining, it is basically you are setting it over here during the type of object initialization. So whenever the Java class loader will load the static thing to the memory during the class loading time, it cannot actually understand what is this T is all about. Because the same T that we have, it need to be shared with all the app class instances that we might have in our Java application. But I also told you this thing. You safely can have a method here, let's say public static method, and Here you cannot define t as well because the sum method is a class level thing. And this t here defined over here as the generic type parameter, which will be instantiated during the app object creation. But the sum method is a static method. And if it is a static method over here, then this method belongs to the class, okay? Not to the object that we're creating over here. So we cannot put t over here. But I told you one more thing that here, if you're gonna make t over here, this thing will work. Why? Because in this case, this t we're overriding over here. Okay, so I can basically call some method and I can pass 10 over here, and this works. And right now, if I can hover on this, you can see this is integer. And if I'm gonna make it something like a string, okay, if I can hover on this, you can see this is right now string. So right now this t is become string and this t also becomes string. So even though my parameter that we have defined for my app class is integer, which is this t, is actually doesn't matter because here whenever I pass this thing, this is basically the type that we are specifying for our sum method t over here, right? So this type got inferred to string. So basically this t is right now that we are overriding from here, right? So basically if you're going to make t, this will be confusing. So you can make something u or e or something else. This might be better, okay? This is absolutely possible and you are able to do this thing and you can write code like this, okay? Because this u right now, it is not a object level thing right now. This u is not tied off with this. This u is right now independent. And this can be invoked separately just by using the name over here. And you can pass anything over here. And that's fine. You can actually invoke this method. Now you might have an outright question over here. If I can remove this, you might have an outright question that, okay, you told me that this static, if you can make, this thing will not work because whenever the class loads, this t will be loaded into the memory by the class loader and this t belongs to the class, right? So the t type cannot be defined during the class loading time because here we are creating the object and whenever we're creating the object, that time only we're defining the type of t. But in this case, this belongs to the class, but whenever the class loading happens, we don't know what is the type of t because the type erasure concept will not work for the static field. That's true. But if this is not possible, okay, then how you are able to create a static method like this where you are making this u like this, okay? And how this u is getting resolved because the static methods are also belongs to the class, right? So if this method belongs to the class, maybe whenever the class loading happens for the app, this particular method also will be loaded into the memory. And whenever it loads into the memory, how Java basically resolve the type for you, right? Because this is also undefined. This will be defined whenever you're going to be invoke them. That time only we know this u is a string. But how basically this particular method loads into the memory, how Java basically understand like the value of u, okay, the type of u, because this is also a generic type. So how can you make a static method type here undefined? And that's a valid question. You might have this question. I suddenly thought about this question and you might think, okay, if the Java type erasure concept doesn't work over here for the static fields, whether the type erasure concept also not work for the static method? And if the type erasure concept is not working, then how Java is basically loading this particular static method during the time of class loading and how it is defining the type of u, right? And that's a valid question. Just understand this. Whenever you work with the static method like this. Now, whenever you invoke the method, that time only this U will be resolved. Right now, what is the U? The U is string. Okay, this U is string, then this U is string. This got resolved during the time of method call. So it is absolutely possible for Java to load method like this during the time of class loading. And there is no problem here. And there is no need to resolve the value for U during the time of loading this method to the memory, because static methods will be loaded into the Java memory during the class loading time itself. It will not wait for the object creation of this particular class. And I will tell you one more thing. The type erasure concept means what? The type erasure concept, I told you, if this is a non-static variable, this is right now not static. This means that whenever we make app of integer, okay, we'll only be able to set this t can only be an integer value, and this is an integer value that we are setting it to t. But this is just for the compile time. Whenever this class will be compiled and bytecode will be generated for the class, in the bytecode, you will not find this t as integer. Rather, this t will just be treated as object. And whenever you're going to be doing this, let's say app.t, whenever you're going to do this, then obviously this t is of object type, but it is automatically going to be casted to integer. So this casting will be done by the compiler itself. Okay, and you will be getting the integer value out of the object, right? Let's say I'm gonna say int value, but this basically app.t will be an object. That object will be casted to integer, and this thing will be done by the compiler. Okay, and the compiler adds the cast over here. Okay, same as this method. Whenever we are calling this method, some method, right? Here we are passing string over here, but here actually we're going to be passing this string in form of object, and that thing will be taken care by the compiler, and this U will be treated as object, and the casting thing will be taken care by the compiler behind the scene. I just want to prove that to you. So first of all, what I'm going to do, I'm going to remove this piece of code. I'm going to come back to this later. So right now, let's just go to this class. Let's just try to compile this class, and let's just see the bytecode. And let's just check one thing here. If in the runtime, the bytecode does not hold the type information, then this type will be of object type. And in that case, whenever I'm going to do app.t, the app.t means I'm going to access this t value, okay, and this should return me an object, okay, and I should get an object value. But implicitly, the compiler is adding a cast here. That's why I'm getting an integer back. Let's just see that cast is compiler adding or not adding. Let's just check that. So I'm going to do one thing. I'm going to go to this class and compile this. So check where this class exists right now. And this is that class. I'm going to copy this class location. Okay. Open up your terminal. So here you go. This is my terminal. So first of all, I'll try to compile my app.java file. So I'm going to say javac to compile, and this is my app.java, and let's run this. Now this app.java file is compiled. That means I should have get the bytecode out of this app.java file. Now let's just try to see the bytecode which has been generated. I'm going to do javac. Sorry, I'm gonna say java p-c to decompile the bytecode, and I'm gonna say I want to see the bytecode of app.class. Let's just run this, and this is the bytecode. First of all, you can see this is my class called app.t. You don't have to understand all this. Just look at what I'm trying to show you. See, there is tt, but I told you this t will be of object type. Let's just see what is going to happen. So first of all, there are some code over here. This code is for your app constructor, and that's the default constructor. Even though if you don't generate any constructor over here, one default constructor will be generated over here automatically by the compiler. So this is your constructor, and there goes some code. We don't give a damn about this right now. Let's just go to our main method. This is our main method code, and a lot of things are happening over here. I don't want to understand everything, but I just want to understand few lines of code. Don't get mad by looking into all this thing. So first of all, I'm invoking the new keyword over here. So if I just try to understand this, I can simply understand, okay, some new operation is going on of my app class, and I'm trying to create the object. Maybe I'm trying to, this dupe has some meaning. Let's not go into that right now. Let's just imagine it is just maybe loading that object from the stack or something, and then it is invoking that constructor, the default constructor over here, to create my new object. This is basically this line of code they are doing. We're not interested for that. Now here we are trying to assign the value 10 to t. Okay, let's just check that thing right now. I will come to here. Okay, so here we are invoking this static method, integer value of I. Okay, so we are creating an integer value of something over here, this thing, and we're assigning it to t. Okay, so let's just see. You can see put field. Here is the important thing. So we are trying to put this value in this field t. So put field is here, and what is that field? Look at that. Now t. So t is what type? java.lang.object. So that's what I said, type eraser. That means this t type will be erased during the runtime. In the bytecode, the t means simply object, and you can see right now put field is putting this particular value of I thing to this t field, and that is of what type? The t field is of object type. Okay, so this t is of object type. Right now you see this line. Whenever I'm going to do app.t, okay, that means I'm trying to fetch the value of t. Now this t is of what type? It's an object type. So if it is an object type, how I am directly putting it to an integer value over here? That means some kind of cast is going on over here that compiler is doing. Let's just see if we can see that in the bytecode, and look at that right now. Here we go. We have the get field over here. That means we're trying to do app.t. That means we're trying to get the field value, and there we go. The t value we are getting, that is of what type? Object type, right? And then you can see the compiler is having a check cast, and it is casting to integer type. That means over here the compiler is adding a cast automatically, and that's why we're able to store that value over here. You can see check cast compiler is doing and casting this object to integer, and there is a store over here. A store means it is basically storing that value into a reference variable of int value, and that's how you can see that this t is right now of object type, right? So I told you about that, the type eraser concept. Now my question is, okay, forget about this code right now, okay, and imagine I will also remove this thing, and let's say if I have a static method right now, as I said, let's say I have some method, I'll define some type here. Let's say I'm going to define a type u, okay, and I will define the type u over here. Okay, now my question is, this thing is allowed. That means whenever the class will be loaded into the memory, this will also be loaded into the memory, right? And this is absolutely fine, and the Java basically allows the generic method to be loaded like this, And whenever somebody calls this method, let's say some method, and then pass in some value like 10, or let's say some string, okay, then only this u will be resolved to that type, let's say string type, okay. But whether this is a static method, my question is whether the type information, this information are going to be erased to object, like this will be object or something else. The type erasure concept works for the static method or not. Let's just try to compile and let's just try to see how this thing works. Okay, let's just go to our terminal, and here I'm gonna first clear out this thing. I'm gonna again do Java C. Okay, sorry, I'm gonna clear out this thing. I'm gonna again do Java C first, not Java P. This is going to be the previous bytecode. I'm gonna do Java C, this one. I'm gonna compile this, and then I'm gonna do Java P. Okay, Java P dash C, because I want to see the bytecode of app.class. Okay, there we go. So this is my generic method. Where is that? We have app.t class, the default constructor code goes here. Okay, this is the default constructor. This is my method, okay, and some method, this is u. Let's just see the u is of what type. Whenever we are calling, so this is the method declaration, right? So this is of u type. This is how the bytecode is holding the thing. Now, where we are calling this method, in the main method, we are passing in some value over here. Now this u becomes string, and this also becomes string. But if the type erasure concept would have worked, then this u should be object. Okay, let's just see. And if I can come to this, sorry, if I can come to this public static void main, you can see I'm gonna invoke static method called some method, and what I am passing here, a string called string. Okay, this is the data that I've given, string. Okay, this is the data that I've given. So this is the value that I've given of string type. But whenever I'm passing that value over here, you can see the value that I'm passing is of object type. Okay, so some method, the value that I'm passing here is of object type. You understand that? So for the static method, the type erasure concept is working over here, and this u is becoming of object type. Okay, I hope that makes sense. Let's say this would have returned me u. Okay, something like this, and let's say return u. Okay, so whatever, sorry, let me say return u. So whatever I'm passing here, it is just returning me that. Now let me just do control1, assign statement to a local variable. So, it is returning me string directly because I'm specifying string here. So if I'm specifying string here, means it is getting inferred to string. That means this becomes string, this becomes string, this becomes string. Okay, and the u is returned to me, which is a string. Okay, now let's just see. Right now I'll go back to the terminal again. I will just do clear, and I'll just do Java C once, and then again Java P once. Okay, now look at that. This is my u method, and here the value I'm passing as string. So there you go. And now whenever you're calling the method, you're passing the value as object, right? The string that you're passing it over here as an object. And then whenever you are returning, whenever you're handling the return type over here, some method, and you are storing it into a variable over here, before that you can see there is a check cast. So the casting is going on and converting. This method is returning me an object, but that is being casted to the string type, and the check cast here is confirming that. Okay, so I can assure you that for the generic type static method, the type erasure concept is still working. But it doesn't work for the static variables.